For this exercise, begin with a basic flat piece with notches that could be laser cut out of MDF. Reference this to a B-rep param and pass that into a mesh param to convert it. Assembler works with meshes because they are computationally faster, and this will have an impact on performance in large assemblages. Note that these must be closed volumes, not open polysurfaces. Following the definition anatomy of setup, simulate, and post-process, begin by constructing a part called an assembly object. The mesh geometry goes into the M input. Plane, direction, and weight can be left at their defaults, but the component needs a name which can be added with a panel. Remember the double-click shortcut for adding components without going to the menu bar. And for panels, an additional shortcut by starting with //. The assembly object also needs something called handles. Handles are the anchor points where two pieces can meet and are a special assembler component. To create a handle, go back to Components toolbar and construct handle. The first input required is an L-shaped polyline. This defines in plane and its orientation. If you've used Grasshopper's orient component before, this works in a similar way. It is best to overscale this for visibility and to put it in the middle of the receiving plane. Before going too far along, quickly add two preview display procedures that will show the rules set more intuitively. Assembler refers to its rules as heuristics, so go to the Heuristics tab and select Heuristics Writer and Heuristic Display. The writer generates the combinatorial rules, and the display shows them visually. Plug in the assembly object to assembly object set input on both, and link the HES output of the writer to the matched input of the display. The display still needs a base point, so add one to your Rhino scene somewhere nearby, but not on top of the module. You can see that the module is represented there, and so is a paired element that has been rotated around, so that the handle positions on both are touching. The preview is in wireframe to show that this is not a valid combination. The two pieces collide when positioned this way. To fix it, first use the handle display component to see how the handle is working. Add a slider to the scale input to show how the attached piece will approach, as well as its orientation. It is rotated around the green Y-axis. If you want this to meet at right angles, the way a notched connection works, a rotation is needed. Add 90 degrees to a panel and connect to the rotation input of the construct handle component, and the connecting plane will rotate around. Zoom out, and the heuristic display will have already updated, showing a valid connection. Of course, the piece could also rotate the other way, so convert the panel from multiline data and add -90. Now the heuristic display shows both options, and the handle display will also show both options. At this point, you may want to change the display option of the heuristic display. Since there's only one object type, the default setting to color by AO type is not so useful. Right-click on the component name and select S/R for sender-receiver status. This colors the base piece blue and the received piece gray. Before continuing, add any other notches as handles by copying and aligning the L polyline and then adding to the curve param. Use the handle display to check that none are projecting into the volume of the piece. If they are, rotate them 180 degrees so that the display is projecting back outward.